Okay, looks like everybody who's coming aboard is aboard. So, I'd like to say hello to you all. I'd like to thank you for taking time out of your busy days to attend today's webinar. My name is Colin McLeod. I'm a digital marketing specialist here at ICP USA, and I am going to be your host. With me today, I have Steve and Robert, our application engineers, who will be joining us at the end of the presentation to help us out with our Q&A session. So if you do have any questions during the presentation, go ahead and enter them into the Q&A section of your little control bar. You should see it if you mouse over the bottom of your screen. Make sure you enter that into the Q&A box instead of the chat box so we can answer it. So if you think of any questions, just enter them into the Q&A box. And if it's something that our techs think that they can answer quickly, they will get back to you right away. If it's a bigger question that we want to answer on mic, might be good for everybody to hear, then we will wait to the end. But we will get to all of your questions at the end. So don't worry if we don't get to it. Okay, that little business out of the way, I think we can get started. Okay, first, if this is your first time joining us, a little bit about ICP USA. ICP, our parent company, was established in 1993. Their headquarters is located in Hsinchu, Taiwan. ICP USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers. We work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning that they are lead-free. We are ISO 9001 certified here in the States, SGS certified in the UK, and we are a a Windows embedded partner. Okay, let's go over the agenda today. Today we're talking about remote monitoring and maintenance, which is a broad topic, I will admit. So this talk is going to be a bit of a survey of some remote monitoring and maintenance technologies, products, and applications. I'm intending for this month's webinar to act like a bridge between last month's talk on OEE and next month's discussion of industrial IoT. So if you have not seen last month's webinar, you can go to our website. Under the presentations tab, you can go to our YouTube channel and see last month's webinar. Again, that's on OEE, or overall equipment effectiveness. If you want that link, you can also email us, sales@icp-usa.com, and we will send you a link to where you can see that video. And all of that goes, of course, for registering for next month's webinar on IIoT. So next month we'll be going into some of the topics we're discussing here in a lot more depth. So today we'll start with an overview of remote monitoring, then look at some examples of remote monitoring systems. Next we'll look at some specific remote monitoring products to discuss the advantages and limitations of wired, wireless, and cellular monitoring systems. Then we'll talk about specific remote maintenance products and their capabilities, look at some examples of remote maintenance systems, and finally wrap things up in a way that will hopefully make sense. We will conclude this webinar with our Q&A session, and after which we will announce the winners of this month's giveaway. So so we have to wait until the very end to hear the winners. Okay. Before we begin the presentation proper, I just want to ask you 2 quick questions. I'm only doing 2 polls this time, so I will not waste any more of your time, but this is a great opportunity for me to get to know my audience a little better so that I can, better tailor these presentations to you and your interests, and just know how specific or how broad I have to make them. It's just it's a good tool for me to get to know you. Okay, thank you. Looks like almost everybody voted there. And second question, is your company looking for ways to move employees offsite? Simple yes or no. This could be due to any reason. Of course, it could be due to COVID-19. You're looking for more ways to keep people safe, keep people separate. So I just want to know, are you looking to move employees off-site? Or have you done it already? That would count as a yes. Ooh, 50-50 split with this one. Interesting. Okay. All right. Now let's begin. Let's get into the presentation proper. So what do we mean when we say remote monitoring? Remote monitoring describes a wide array of tools and technologies that allow users to track machine status and sensor data from a remote location. Much of what we do here at ICP USA can be described as remote monitoring. Take, for example, a very simple data acquisition solution. With the kind of Ethernet network you find in every office building in America, you can very quickly put together a remote monitoring system for one floor of an office building, wire it directly into a desktop in another room. This is a data network you could potentially build with office supplies, regular Cat5 Ethernet cable, could even use some spare Cisco routers you have laying around. You just need to get the data acquisition modules and the sensors. So you can imagine, with not a lot of setup time, you can see how you can keep track of things like room occupancy, power consumption, temperature, CO and CO2 levels, light and HVAC status. This is the bread and butter of what we do here, but it's not really the first thing I think of when I hear remote monitoring, but it certainly applies. I mean, even if it's just in another room. So that's sort of the framework we're working with here. But I wanted to get into an example of something that's a little bit more remote, in my opinion. So this is a system built to log data from a river for water quality monitoring. Now, data logging refers to the process of collecting and storing data from remote sensors, I'm sure, as you know. And then you analyze that output with a computer, often at a remote location. So what we have in this example is a remote water quality monitoring station with a number of sensors. There's a seismometer, liquidometer, and thermocouple, all of which are connected directly into our GT543GWA, which is a 3G data server that you can use to transmit that data using a 3G signal over the internet to your remote PC controller. So with these instruments, you can measure water temperature, water levels, and volume of runoff flow with the seismometer. So you can imagine that if you put a string of these stations at key points along the river, you'll start to get a picture of its overall health and status. The data is taken by the GT543GWA and transmitted to a remote PC back at Water Department HQ. Connecting the 3G data server to a remote PC is a straightforward process, and there are a couple of different ways to get data off the server. You can establish a live connection through our OPC server and log data directly onto the PC. But the server also has a data logging function, and you can schedule it to send your data in batches by email or FTP while the day's data is stored on the SD card. So this is one option for long-distance remote monitoring, which is really what I was thinking of when I chose this topic for the webinar. For the next example, I want to show you two more ways to transmit data over long distances. So ICP DAS put this application together for a municipal water plant that needed to monitor groundwater pumping, storage, and treatment. I didn't intend for so many of these examples to be water-based, but they are useful just because of the distances involved. There's a lot going on in this example that we could talk about, but I want to focus on how the system was connected when each pumping station and the control center were separated by a couple of kilometers. In this example, the customer had been using two-way radios for data transfer, and they wanted to upgrade this to a fiber-optic solution while leaving the RF system intact as a backup. So at the top of the diagram, you can see the control center. This is represented by the little PC icon. It's running an Indusoft server that will monitor and control activity at each individual station while making that data accessible from remote workstations and even mobile phones. The control center is wired using an available Ethernet port or via a router, and then connected to an NS200 FCS single-mode fiber gateway, where the signal is carried 3 kilometers to the first pump station. And with our single-mode fiber media converters, your max transmission distance is 15 kilometers, just for reference. So at the other end of this line, you will need another NS200 FCS if you want to convert your fiber signal back to Ethernet and then connect it to the local Ethernet network at the pump station. In this example, the fiber network is converted back to Ethernet and then connected to the local controllers that manage water levels and water purification processes. And at the bottom of the diagram, you can see the fiber network is directly connected into an RS-485 network using one of our PDS-220F family of fiber to serial device servers, which allows you to interface directly between your fiber transmission network and one or more serial lines. In this example, you see we have a multi-drop setup connecting I/O modules and power meters at each pump station to the local touchpad, that's a viewpad controller, which is then wired right back into the fiber network. Again, the advantage of a fiber network is a very fast connection that doesn't have the range limitations of serial, Ethernet, or radio. Speaking of which, you can see in the diagram that at each pump station we did keep the RF transmitters intact. They've been left as a backup in case anything happens to the fiber network. An RF modem is certainly an option for this kind of outdoor long distance application, but there are some limitations which we'll get to in a little bit, and we do actually have a better recommendation than an RF transmitter, or than this kind of RF transmitter, different wireless network. Okay, so now that we've seen 3 different examples of remote monitoring systems, I wanted to go over some of the advantages and disadvantages of each method. Since it's fresh in our minds, we'll start with our fiber optic media converters. In the application story, we talked about the NS200 FCS and the PDS-220F. The first is an Ethernet, that is the NS200 FCS, is an Ethernet to single-mode fiber media converter. And the second, the PDS, is a fiber to serial device server. In the diagram on the screen, however, you can see the NS205 AFC-T and NS206FC. The designations are not very important. What I want you to know is that these are multi-mode fiber optic gateways. And I wanted to include those to briefly touch on the differences between single and multi-mode fiber, and point out that yes, we do sell both kinds of converters and gateways, single and multi-mode. You can convert between Ethernet, serial, and a couple other field bus options. For this application, all you really need to know is that single mode carries data over long distances, up to 15 kilometers in our case, in the case of our equipment, and multi-mode fiber is used for shorter distance, usually less than a kilometer. So multi-mode is useful for connecting remote stations. Single mode is useful for long distance connections, like the remote pump stations that we saw in that last example. And multi-mode fiber would be very useful for connecting for a data network on the factory floor, or one building, or one floor of a large building. So you can kind of see how those are used. Anyway, in the last example we mentioned RF modems, a product that we do sell, but I would not recommend in this application. For a long distance outdoor application like this, we would actually recommend a Zigbee mesh network. So some of you may be familiar with Zigbee. It sees a lot of use in home and building automation. Like all of our radio transmitters, the max distance is 700 meters line of sight. But the advantage of Zigbee is its mesh topology, so you can use repeaters along the transmission route to extend the distance, which isn't possible with our with some of our other RF transmitters. Right. Zigbee is also very useful on the factory floor or any other situation where you don't want to have to snake a bunch of cable long distances around machinery. As long as the modules are within sight of each other, they will be fine. Another advantage of Zigbee, at least from our end, is that we do sell a lot of Zigbee end devices, namely digital and analog I/O modules that can capture data directly from your sensors and transmit it back to the mesh network, and that way you don't have to worry about setting up a bunch of converters and gateways between your Zigbee transmitters and your DAQ modules, which are probably Modbus RTU, RS45, RS232. These ones are Zigbee native, you might say, DAQ modules, so they connect right to the Zigbee network. All right, and the third option there at the bottom would be our 3G data servers. Before we mentioned the GT543GWA. I wanted to talk about that in detail for just a little bit. So the GT543GWA is a 3G, which is a WCDMA data server with the data logging function. Has 6 digital input, 2 digital out, 1 analog input, an RS232 and an RS45 COM port, and an SD slot for onboard memory. It can be used in M2M application fields to transfer the local I/O or Modbus device's data via GPRS by the defined period or digital input or analog input triggers. The local I/O data can also be stored in the SD card to become a remote data logger. For another communication path, GT543GWA offers the email mode to transfer data by email via 3G, and users can choose which data transfer method they prefer. The GT543GWA is a great product for environmental monitoring and remote device management. It's supplied with an easy-to-use API and our OPC server software, which streamlines the application development process and the remote data logging use. So the main advantage of 3G is that you can transmit data almost anywhere as long as there's cell service. With a 3G data server, you don't need to create a bridge between two modules like you would with RF or fiber. You can receive the data on a smartphone, PC, or another internet-connected device. The downside of a 3G server is that you need an activated SIM card. You are beholden to the quirks of whoever your cellular provider is, and there are the ongoing costs of a cellular plan. All right. So now that we've looked at some examples of remote monitoring systems and have a good idea of the long-range transmission methods available to us, I want to speak about some tools that are specifically designed for remote maintenance. Now, all three of these products that you can see on your screen have one unifying purpose: to allow an operator to control a machine from anywhere in the world as if they were in the same room. What these modules do is they establish a digital pair connection between a remote maintenance tech and a PLC, PAC, or other machine on the factory floor or in any remote location. Basically, you pair two or more of the same modules together to create a virtual COM port that you can use over the internet or local intranet if you just don't want to have too many people in the same room. Additionally, all of these modules provide a voice streaming feature, so with a microphone on one end and a speaker or headset on the other end, the remote maintenance tech can communicate with on-site personnel directly and control the machines as if they were there themselves. So a little more specific, that first module was the M2M710D. M2M710D is a device specially designed for remote maintenance. It's built to withstand harsh industrial environments and provides two major functions: the digital pair connection and voice streaming. The pair connection provides TCP data tunneling between two serial devices. Therefore, by means of TCP/IP server client infrastructure, M2M710D can provide the remote serial data transmission by Ethernet between local and remote users. The maintenance engineer can directly check and diagnose the device as if they were on site, so it allows you to create a digital pair over internet or intranet between a remote PC and one serial device on the factory floor or in the field. So basically you have one M2M710D connected to the PC and another connected to your local PLC, and the remote maintenance tech can see the machine status and operate device as if they were there. So the M4132 provides the same basic function. The advantage is that you can use one M4132 in server mode to establish a connection between many other M4132s in client mode around the world. And like I said, it provides basically the same function, but in a one-to-many configuration. So you can have one remote maintenance tech operating all these machines separately or at the same time. So the last option is the M2M720A, which expands on the one-to-many communication provided by the M4132. It can work in server and client mode just like the other two options, but in server mode it allows you to connect to any and all of the previously discussed modules. The 710D and the 4132 can only connect to different versions of themselves. And that pretty much wraps up our discussion of remote maintenance devices. These are fairly straightforward modules that allow you to create a digital pair connection or a digital COM port between a maintenance tech in one central location and one or many sites around the world. These modules allow the remote tech to operate devices as if they were on site, and the voice streaming allows them to work with on-site personnel to perform necessary maintenance. So I hope you can see how this can be not just a cost and time saving measure, but also now a way to protect employee health. So that is going to conclude our discussion of remote monitoring and maintenance. I hope you found this useful. I tried not to throw too many part numbers at you, and I hope that you will leave here with a better understanding of the different options you have for transmitting data over long distances. And I hope you know a little bit about our remote maintenance devices. I do hope you will tune in next month for our talk about IIoT, something I think you will find very interesting. All right, I would like to open up the floor to any questions before I announce the winners of this month's raffle. Again, if you have any questions, please enter them into the Q&A box now. So, that concludes this month's webinar. I want to thank you again for taking time out of your busy day to listen to me ramble on, and I do sincerely hope that you learned something, that you found this valuable, and please do sign up for next month's webinar. So, thank you all. Thank you for attending.